So we'll come back looking at rational functions. And in this video, we're going to look at horizontal asymptotes. Last video, we talked about vertical asymptotes. And again, an asymptote, we talked about the vertical asymptote. That's kind of this, whoa, that looked horrible. Let's see if I can draw this a little better. Well, not really. A vertical asymptote is when we had in our graph this kind of vertical line. And as we look at our function, as it gets closer and closer to that line, it either shoots up to positive infinity or it shoots down to negative infinity. But it never actually equals to that because this is where the denominator equals 0. So we found those vertical asymptotes by setting the denominator equal to 0 and solving for x. So what do we mean when we talk about a horizontal asymptote? Well, a horizontal asymptote is going to be basically when we're looking at the end behavior. So when we see, because if we think about the vertical asymptote, we're looking at here, oh, x is shooting up or x is shooting down. When we're wanting the horizontal asymptote, we're looking more at what's happening at the very ends, what's going on. And we're going to end up having basically three cases. So case number one, it's going to die off. Or this is going to be approach 0. We can have level off, where we approach some number. And then we're going to have keeps. I'm not going to say keeps. I'm going to say goes to infinity. To infinity and beyond. And we could be plus or minus. So this is going to be like a polynomial. So when we look at the end behavior for this, we can approach 0. We can die off to 0. And we kind of saw that in some of our exponential functions. Back when we looked at geometric sequences, some of them died off to 0. We can have level off. That's kind of dying off, but it's hitting some number besides 0. These two cases put together are what we're going to talk about here. These are horizontal. Because if it's approaching 0 or approaching number, it's going to flatten out, and that's that horizontal asymptote. These ones here where you're going up or down to positive or negative infinity, we're going to look at this later. We're going to look at this in another video. So we're going to just focus on these two ideas, where it dies off and where it levels off. So we're going to start playing around with some graphs. So let's start with this one. This is an example of it's dying off. As you see, as we get bigger and bigger, if I look at my ends, they're getting closer and closer to 0. If I were to, go off to negative 100 and positive 100, you see even better that this is just getting down to 0. The idea, okay, I got 2 pizzas. I spread it among 4 people. Hey, that's not too bad. Each person gets half a pizza. If I spread it among 40 pizzas, we're getting less and less. If I spread it among 400 people, pretty soon we're getting to the point where nobody's getting any pizza because there's too many pizzas and not enough pizza. Too many people. So if we go a table here, we're going to, again, make this f of x1. And if we go 1, we're good. We go 2, that's getting less. We go 5, 10, 100, 1,000, a million. 2 times 10 to the negative fifth. That's pretty small. Okay, 0.00002. But what happens if this number gets bigger? If I go up to 20, hey, 20, 10, 4, we're still not too bad, but we get down to a million here. Oh, that's not a million, that's 100,000. Here's a million. We're again going down to 0. Let's go 2,000. Okay, it's off my graph here because I'm only going up to 6. I mean, got numbers 2,000, 1,400, 210. But again, we get up to a million and we're at 0.02. Again, this looks like it's coming down towards 0. Doesn't matter how big this is. End behavior, x is going towards infinity. And even if I bought a million pizzas, if I'm trying to feed billions of people, still nobody gets anything. And so this is what we mean by dying off. And we're going to die off anytime I have a number divided by anything with x in it. So whenever my numerator is just a number and my denominator has x in it, it's eventually going to be 0. You get x big enough and it'll be 0, no matter how big your numerator is. So that's my first case. That's when I have dying off. Let's make a note on here. It dies off when you have your f of x equals some number divided by x. So how do we get it to approach a number? Well, probably if we put something up on the top here besides just a number. So let's see what we can do. Let's, instead of going, what if I go 2 plus x? Well, that's hard to see here. Now if we look, this doesn't die off to 0 anymore. But if I make this, let's spread this out a little bit more. Let's go again, 100, 100. And we look, it looks like it's flattening out here, right at about 1. If we look at our table, okay, we up to a million, we are at practically 1. These are getting closer and closer and closer to 1. I change this number. Now I'm off the graph, but if we look at our table, again, we get up to a million and we're basically 1. So this number doesn't seem to have a whole lot to do with it. What if we put a number here? I made this 2, and now you look here, it's flattening out to 2. I make this 7, you can see it's coming down to 7. So it has something to do with this. Let's say I don't want 7 and 7. Let's go 3 and 5. So we start 1, we're 8, but now we're coming down to 5. And why is that? If I start off with my function, oh, that's too thick. Let's thinner that out. Okay. I have my f of x equals 3 plus 5x over x. Since I'm dividing everything by x, I can break this down to 3 over x plus 5x over x. Because, if I think I'm adding my two fractions together, they have a common denominator. So I just add the numerator, 3 plus 5x. As long as this is just a single term, I can divide. I can come along and divide this by x and this by x. 3 over x plus 5 over x. Well, 3 over x is just 3 over x. And we said before, a number over x, as x gets really big, is going to become 0. So I don't care about that one, because I'm looking at end behavior just at the ends. But 5x over x, the x's cancel, and I get plus 5. So we're going to end up with an asymptote. My end behavior, this looks like, when x gets really big, this just looks like 5. So I can come down here and put in the line y equals 5. Oops, I can't do it there. Let's do it here. I'll make that a dotted line. And there's our asymptote. There we're going up with it here. So let's see if we can figure out some other ones here. I'm going to get rid of this table. I'm not going to graph this. Let's go 5 minus 4x. And let's make this a 2x. So what do you think is going to happen here? We use that same idea. 5 minus 4x over 2x. 5 divided by 2x minus 4x divided by 2x. Here again, I have a number divided by an x. So as x gets really big, this is going to look like 0. Here, I can say x divided by x cancels out, and I get 4 over 2 is going to be a minus 2. So my function looks like 5 over 2x minus 2. And I said as x gets big, this goes to 0. So I should have a asymptote at y equals negative 2. So we'll take this down to negative 2. Whoops. So there's where I say my horizontal asymptote is. I can look at this and say, hey, I should have a vertical asymptote. If I remember before, where the denominator is 0, so that should be x equals 0. So let's make that also dotted. Let's change the color. We'll make that red, dotted. So those should be our asymptotes when we look at this graph. And sure enough, we can see it doesn't cross the y-axis, so we're at 0. we level off at -2. Hey, hey, hey. What if I change this down to now? Let's go 2x minus 5. And we're going to make this one x plus 3. On this one, I can't do the, hey, just divide both of these by x, because I got an x plus 3. This is a full unit. I can't break apart the denominator. It has to stay together. So what I'm just going to do is divide this. If I go and say 2x minus 5 divided by x plus 3, I'd say 2x divided by x is 2. So 2 times x is 2x. 2 times 3 is 6. We subtract that. So -5 minus 6 is -11. That's my remainder. So I can look at my function. 2x minus 5 over x plus 3 is going to equal 2 minus 11 over x plus 3. But again, this is a number divided by something. We said that dies off. That goes to 0. So my end behavior here, my horizontal asymptote, should be at y equals 2. My vertical asymptote should be where x plus 3 equals 0. So that should be at x equals -3. So let's put those in there. X equals, we said, -3. Y, we said, should equal a +2. And let's put in, those are my two asymptotes here. And let's put in this graph. And we can see it looks like that vertical asymptote looks good. Horizontal asymptote looks good. It looks like it's approaching that -3. This is our big idea, to find the horizontal asymptote. We're going to get into this deeper. Now, the bad news is we're going back to everybody's favorite, polynomial division. But we're looking at a fraction that's basically division. When we do that division, we end up with a remainder, if it doesn't divide evenly, is going to be, in this case, I'm dividing by an x. I'm going to have a number over x plus 3, or a number over an x, which is going to go down to 0. And if I get a constant here, this will be a horizontal line. If it's not a constant, we'll look at that, as I say, in the next video, where we're going to say it's going to start working like a polynomial. But you can maybe get an inkling of what's going to happen here. So coming back to this, it's going to level off or approach a number if f of x, we're going to have, again, a function of x, so we need an a of x, and we need a b of x on the bottom. And we're going to try to see what's happening, we're going to divide this out so that it gives us a number plus a number over my x. If when we divide these two, we can simplify it down to a constant, plus one of these ones that dies off, then that constant is going to be my and behavior, my horizontal asymptote. On here, the die off, my horizontal asymptote is always going to be y equals 0. For this level off, it's going to be y equals some number. And these are going to come from this division problem. So finding horizontal asymptotes pretty much comes down to take the numerator divided by the denominator. It's nice when the denominator is just a monomial, a single term. Then you can divide each term of the numerator, and it works the other way, slickly. Otherwise, we got to divide. Now, if we get anything here, if we get any x's in this part of it, then we're going to have to go to our third option, and again, we'll talk to that later. There's horizontal asymptotes for you.